Our ancestors also looked to the night sky and made other observations to make sense of the world around them. For example, the fact that the Earth is round. The idea of a flat Earth was never quite as widespread as you may have been led to believe. In fact, many people in different parts of the world independently came to the conclusion that the surface of the Earth is actually slightly curved. And there are some very simple observations which will show you this. Imagine that you're at a harbour and you're watching a boat come in to port. First of all, you see a little dot on the horizon. That's the very tip of the sail of the boat. As it comes closer to port, you begin to see the sails, and finally, when it's close enough, you can begin to see the whole ship. So this made people realise that the surface of the Earth is curved. As far as we know, the ancient Greeks were the first people to realise that a lunar eclipse could tell you something about the shape of the Earth. It was clear to them that a lunar eclipse was actually the shadow of the Earth being cast on the moon. If you've never seen a lunar eclipse, it's a lot easier to spot than a solar eclipse. You don't need to be in a particular part of the world. It's seen over a whole hemisphere of the Earth at the same time, and it's a really beautiful sight. What you'll see is this dark shadow crossing the moon, and once the moon is completely covered by the Earth, it has a really beautiful deep red colour. What that is all of the sunsets in all of the world shining onto the moon and giving it a beautiful red glow. The key thing about the shadow that we see is that it's always curved. It's always a circular shadow. And the only shape that can cast a circular shadow, regardless of how it's orientated, is a sphere. So it was immediately clear to the ancient Greeks that the shape of the Earth is actually spherical. Not only was it possible for people to deduce the shape of the Earth, but the ancients even managed to deduce the size of the Earth. And this was done in Africa over 2 millennia ago. A philosopher in the city of Alexandria on the Mediterranean coast heard that there was a place to the south of him where it was well known that on the longest day of the year, right in the middle of the summer, the sun was directly overhead. This was known because when you looked down into a well, down that vertical shaft, you could actually see the sun reflected in the water. So what this ancient philosopher did was he looked at the shadow that the sun cast at his location in Alexandria, and he measured the angle that the sun made with the vertical in his location. He was then able to tell the difference in angle between the vertical where he was and the vertical in the place to the south where the sun was directly overhead. And he was able to compute that by travelling from this southern location to where he was, you would be going around about a 20th of the Earth's circumference. So simply by knowing the distance between the two locations on Earth, he was able to work out the entire circumference of the Earth. Now there's a little bit of uncertainty about exactly what units of measurement he was using for his calculations, but it's certain that the answer that he got was within 10% of the current value, and it may be as good as 2%. So here we have a measurement of the size of the Earth from over 2,000 years ago, which is in great agreement with the value that we use today. At these early times, most people assumed that the Earth was at the centre of the universe. And this means that everything else, including the sun and the moon, are moving around the Earth. And even the stars have to be painted on some big celestial ceiling which goes all the way around the Earth. People assume that if we were moving, that we would feel that motion in some way, or maybe feel the winds from that movement. And so it was much easier to assume that the sun and the moon that we see during the day and the stars and planets that we see during the night were moving around the Earth once every day while we remained stationary. Over the centuries, however, this model was called into question. The first, as far as we're aware, were ancient Greeks who deduced that the sun was actually much further away than the moon, and that the sun was therefore much bigger than the Earth. Other careful observers in places such as India also made observations which suggested to them that having the sun at the centre of the universe with the Earth moving around it was a simpler model.